So far, we've gone through the empathize stage to really understand more about people, more about the particular person that we're trying to solve the problem for. We've started to define the actual problem that we're trying to solve. And I did get some questions during the break about how does this actually align with the company itself. And so one thing I just want to say to everybody here is that this design thinking framework doesn't always take into consideration how a company makes money, right? Like it does try to understand how a particular person would have a problem solved that would be valuable to them. But this idea of intersection with the company strategy, things like that, I'm sure there are people that have talked about this a lot from the design community. I have other ways that I think about the idea of linking strategy to day-to-day action and understanding about our customers. But I just want to be clear that design thinking is a framework and a set of tools to use to understand people better. You can take any of these exercises and turn it at the internal stakeholders or people that are within a company to better understand what they need also. So it doesn't always have to be the end person that's actually utilizing the software or the app or something like that. We started doing some ideation, and we did that through the empathy mapping for the machine. And so if you want to take a bunch of photos of the stuff you guys put up there, you can use this as like, hey, I've done design thinking. And I'll take a photo of you like looking really pensively at the Post-it notes. We're going to continue on with ideating. And I'm going to talk about one other tool that I've used that is specific to kind of machine learning and AI systems. And it's what we call confusion mapping. And so I love this quote from Alan Turing, and he was actually referring to mathematicians in this case, but if a machine is expected to be infallible, it cannot also be intelligent. And what he means about this is that for machines that are doing something that is what we perceive as intelligent, in some ways requires exploration. Because you're defining something new about the world, you're synthesizing something new about the world, you're learning something or figuring out a pattern or generalizing something from the world that was not maybe understood before. And so in those cases, though, that exploration also requires failure. And so when we talk about, and the way that this will work when we're building things like models is usually it is related to this confusion matrix. And so this is the animated one that Google used, and I love using it. But essentially, this is something that's used a lot in statistics circles. It's used a lot for machine learning, performance understanding. But it's basically that if you're not familiar with this type of graph, prediction is what did the machine learning model think something would be, and then reference is what is the truth that we know about the world. And even that gets a little tricky sometimes. But when we talk about a positive situation where both the reference of the world was true, say, and the prediction was true. So let's say that it was a picture of a dog, and the classifier thought that there was a picture of a dog. That's a true positive. If there's the case of the negative in this case, the true negative is where it thinks that there's no dog in the picture, and there is no dog in the picture. And now confusion matrices can get really big where you have basically a column or a row for each individual classification if you're doing that type of prediction. But the parts that I really want to talk about right now are really these false negatives and false positives, right? So it's very, very interesting to understand how the machine will do the wrong thing. In the case of, say, a false positive is that it thinks that something is true, but it actually isn't. So in the case of the AVs that we were just talking about, a false positive would be that it thinks there's someone in front of the car, but there actually isn't, right? And so in that particular case, that's probably much less worse than a false negative, which a false negative is where it doesn't think something is true, and it actually is true. And so let's use the AV version of that again, is that it thinks that there is no person in front of the car, but there actually is, right? And what I'm less worried about the idea of the false positive or false negative cases, and I'm more worried about what is the action that takes place after that. And so in the case of an AV, a false positive would probably be that it thinks a person's in front of the car and it slams on the brakes. And so that's annoying to the passengers, that's annoying to the other cars. There could be other problems with cars, say, rear-ending that car. But the truth is that's way, way less worse than not thinking there's a person in front of the car and just running them over. Now, the reverse is true also. So it doesn't necessarily mean that false positive or false negative is good or bad. So false positive could be if you're using some type of software that is trying to diagnose certain types of cancers based on x-rays. A false positive would be that it thinks there's a cancer there, but there actually isn't. And so in those cases, it could cause a series of kind of surgeries or interventions that could be life-threatening as well. So that's what we mean when we're talking about a confusion matrix. Confusion mapping, though, and so part of the reason why we do this, right, is like non-deterministic systems, they fail. They fail in ways that we don't necessarily always know, but we need to learn about them. Accuracy is not the only reliable metric, right? We talk about machine learning as a classifier or as a predictor. That's important and that's helpful, but sometimes this accuracy number can be low but still be good in some way. And so confusion matrices are another way to understand that. When we talk about the idea of confusion mapping is we're really trying to discover the potential worst case scenarios and then start that discussion, really. That's really what this is. And so the way that we do this exercise is we do something very similar. We're not going to do it here today, but it's very similar in the way that we did the empathy mapping for the machine. We draw a confusion matrix, and we talk about, in this case, what would be false positive, what would be true positives, what would be true negatives. But what I'm really trying to get to is what are the false positives or false negatives. And so, again, taking the example of the car, the idea of a false negative could be very bad. And the way that you then do this is you privately ideate for each of the sections, like we did last time. And the reason why is because we're trying to understand from everybody on the team's point of view, what does it mean to have a false positive, and what is the impact of that false positive or false negative? You repeat for each of those sections. You can do true positive and true negative, but I kind of feel like you cover that within the feel section of your empathy mapping for the machine. And then vote and stack rank the severity, basically. And so I found this to be really helpful. We're not going to do it today, but I mean, I'd love to hear, are there any ideas right now? What would be like, in the case of the AV, what would be a bad false positive? Mistaking red for green? And you can take it both ways, by the way. That's exactly right.
Is it a red light detector, or is it a green light detector, or is it a...
Well, so in this case, I think we're trying to open it up to understanding of like for an AV in general, right? So yes, there will be times when you're doing this, you'll find overlap between false positive and false negative as mirror options. That's absolutely true. And so anyways, that's an example of something. I think that's a good one, so that you'd think that. What would be another one maybe? Maybe like, yep, all the way back? Yeah, so thinking that someone on a bike is another car. Yeah, I mean, if you look at what happened with like Uber, for example, right? Like there were a couple different failures of different sensors, but in the end, there was actually a trust issue here. I won't go into that right now, but yeah. So I think that's a good example. Another one might be that it thinks someone's in the car still and they're not, right? What would be the impact of that? It still goes to its destination. Or it thinks no one's in the car, but there is actually someone. And so then it goes and picks up another passenger, right? So these are like lower cases. But anyways, I think this is an exercise that I found to be really interesting. And I've used this a lot. In other ways, people can be very creative in a pessimistic way. So I don't know if people have heard about like premortems, but it's a really interesting technique about asking if we were to do this project and in the future we failed, why did we fail, right? So it's a very interesting technique to get that. And that's what was really inspired this idea of doing something like confusion mapping. And so after that, after you do confusion mapping, you have a set of important kind of worst case situations that you need to consider. And so it could be that you need to consider them in the sense that you need to build redundant systems. It could be that you need to consider like ensembles of systems to do a better job of detecting that. We're not even looking at frequency yet though. Right, like that's the part that I think is interesting about this exercise, and that's why, like again, you're not allowed to use AI jargon when doing this type of exercise. Is that you want everybody to be able to contribute to this type of thing, and maybe you get to the point that you're discussing like why certain worst case outcomes are the most important to end users, right? And from the standpoint of again human-centeredness, and not necessarily just the person that's in the car in this case, but also potentially pedestrians and people in other vehicles. That's confusion mapping. What I want to move into now is prototyping. okay? And so prototyping, this is the phase where you're starting to build something. It doesn't necessarily mean that it's something that is fully fleshed out. It doesn't even necessarily mean that it's a website or an app, or even it looks like a website or app. But it's something that is symbolic for you to start having a better conversation or a more detailed conversation with the actual person that you're going to be impacting. And so I wanted to talk a little bit about UX patterns, especially when it is related to machine learning and AI. And so the first one that is really used an awful lot is assistive, right? So this idea that spell checking is a service that's available to me that while I'm doing some action, it actually helps me do a better job at it. Maybe helps me reduce error. It helps me think about more things than I would have, that type of thing. So that's assistive. There's automated or agentive. So this idea of that you kind of set something up and then it goes off and it just does something. The way that, say, Nest is kind of you set the parameters in which you'd like your house to exist, and then it does its job to try to keep it within that range based on other factors. There's a really good book, Designing Agentive Technology, by Christopher Nacelle. And he has a lot of other great talks about kind of interesting techniques as well. But he makes a distinction between agentive and automated, and I'm not exactly sure whether there is much of a difference. I think I'll leave that for you to decide to read or not. But again, in this case of agentive, there's some agent or system that is off doing its own work out there. And these are the 2 or 3 ways that a lot of people think about AI and machine learning, but there's actually another one that I think we should consider, and that's generative. And so generative is that we, as human beings, again, are constrained in the way that we think about things. We assume certain things are important and others aren't. But when we do a good job of trying to set what the outcomes are that we're trying to get to, machines can in some ways probably do a potential better job of exploring that complete space than we could. So this is an example of, I think it's AutoCAD's system for generating, so essentially the human being sets up the constraints that they need a particular piece to have these type of bolt spots, and then it needs to withstand these types of either kind of strains or weight bearing. And then this system uses those constraints to consider things based on material creation. And in this case, it could be like a 3D printing output to build something that is better than what the human being probably could have done, because it has a better ability to explore that space of the physics of the problem. And so in this case, it created something that looks very odd, but uses less material, which is something it's trying to optimize for, and is able to bear potentially the same or more weight than it would have otherwise, but then still meet the constraints that the human being set, which is that this part needs to exist in this space. So generative is an aspect that, when we were thinking about it from the standpoint of field service operations, scheduling is a little bit of that type of task, right? So creating a bunch of different schedules and then ranking them based on fitness is a very important way to do that. I've been starting to see people utilizing this for creative work. So being able to, based on some topic or beginning of a sentence, auto-generate sentences that are afterwards. And it's not meant to say that this entire piece of fiction can be generated by a machine, but that you could use this as a jumping off point for the human being to now create something that is very creative. So these types of generative things, people don't always consider them. And so I just want to make sure that when it comes to UX patterns and how people interact with these systems, generative is a very, very key one. And I think will actually be a majority case for the future. Right? Once we start to automate everything when it comes to efficiency, we then have to create better things. And some of that time requires human ingenuity paired with the ability of machines to do a better solution space search. So talk a little bit about UI patterns. And this is maybe getting very, very particular in things that we've learned through our different engagements when we've built systems that utilize machine learning or AI, or would potentially utilize machine learning and AI. One of the first concepts that I think is important when it comes to user interaction, this is the automation levels for autonomous cars. And so they go all the way from there's no autonomous features all the way up to pure autonomy. And I think this is the way that we really need to consider things when we are talking about how people and machines interact with each other. And so at the very, very beginning, you start to have where the human is doing everything. And that's most cases today, right? Like people are actually off. They're doing their job as they usually would. Data is being generated in some way. It's being stored potentially in some way. Maybe it's not yet, but it could be. But the truth is that the machine at that point is really learning. So it's looking at data, it could be, and it's watching, essentially. So it's not taking action yet, right? Then the next step is we start to get into this point of view that machine action is recommending things. It's starting to say that you should do X in this particular situation, and the human is confirming it. And the last one is really this idea that the machine is now automatically taking action, and there's some way for the human to veto that. I've seen lots of other frameworks that try to break it into like 10 levels of autonomy. I think this, to me, really kind of distills it down to the main three things that you need to think about. And most of the things are really at that bottom level to start. And that's where you need to start to consider that if you were to go up into those higher states of automation, what data do you need to do that? What outcomes do you need to understand? And how do you do it in a way that allows the human to intervene in some way that is really impactful? So I think this is like something, I start to think about this as stages as well. So even though we may prototype things that are more of an end state, you need to consider some of these intermediate states as well. And in particular, you're going up as you get confirmation that the systems work the way you think they do, basically. So one thing that we've thought about a lot is this idea of an intelligent call to action. So it's something that we do a lot of the time when we're trying to either personalize workflow tools, try to do this a lot, but they do it in maybe a more rigid way where it's trying to understand through a workflow what to happen. But we've used a lot of these types of call to actions as buttons, and in this particular case, it was whether a job should be assigned or not. Within these prototypes to understand how people understand a machine starting to take on automated action. And so in this case, that CTA is in the same place within the user interface, but it's changing what is possible based on the action, but it is doing it in a way that is non-deterministic. And so anyways, we'll get into this like in the testing section about what that means, but it's important to start to think about that. Generating options. So like we said, generative approaches are really, really helpful, I think, for humans, especially when we're talking about exploring solution spaces. In this case, we were talking about a schedule generating system and the explanation of that. Next thing is explainability, which I think this is a hilarious tweet where the mom asks, "Why did you kick your sister?" And the kid says, "Because my attention was on her." And then the mom says, "Be more specific." And the kid says, "Because of the vector." And the mom says, "Huh?" And the kid says, "C embedding 122, 01, 13, 23, 99. And then the mom says, "Don't make me decode that vector, kiddo." And so this is a joke about explainability, but I think this talks about the glass box of machine learning, right? That you can know very intimately why something is making a decision based on all the neurons and the connections between those neurons or nodes, but it's not actually helpful to people most of the time. And so interpretability is way more important in this case. And I'm sorry if I'm being pedantic about the difference here, but the truth is explainability of why an algorithm works versus how that person does a better job of interpreting what they should do next, I think is a very key distinction and is very much related to design thinking. So in this case, when we talked about interpretability of why a perfect schedule is being found, this is very much, we stole this basically wholesale from TurboTax. So whenever you're filling out TurboTax and it says, "I'm optimizing your return," and it's saying, "I'm checking this, I'm checking that," it already did all that. It's just telling you, it's taking you on this journey to understand all the steps it took to get to the end point. And so in our case, we were showing this within basically a group chat view where Patrick was helping in some way. And this tested really well as far as understanding for people about why scheduling decisions were made. The next thing is to help humans avoid errors, and this in particular, I meant for it to be blurry. But one of the things that we maybe do, and I'll talk a bit about this in the trust sections a little bit later, sometimes we try to do too much to take over the job of a human being, when the reality is efficiency or benefit could be helped by just reducing the number of errors that they make. And so, that idea is something that I find people struggle with, where they try to go too far when it comes to automation. And trust, again, I'll talk about this a little bit later, but it really comes down to that if you try to take over too much of that job up front, you may lose trust with the human that's trying to interact with it. And then being upfront about possible errors. This gets back to trust, but being able to show a lot of error messaging within an interface is really, really key. And so for Patrick, in this case, being able to say and set expectations for when it is wrong, and if it is detecting that its confidence is low in something, was very helpful. And it helped build, again, the mental model of people before they got to it. allowing intervention or appeal. So this is incredibly key. One of the biggest problems, right, is that you are not allowing human beings to actually do the things that they do best, which is anomalies, right? Machine learning or AI can do a job where it can detect anomalies, but it doesn't necessarily know what to do with them, potentially. And so from this perspective, in this case, we did in the field service operations, we made it very easy for, even though we make recommendations about field techs that should be assigned to a job, we made it incredibly easy for that dispatcher to make a quick change. And this is related to the next point, which is that feedback is incredibly important from the humans, right? As we start to build things that are doing a better job, we need to understand more context from humans themselves. And so in this case, being able to get feedback, if they had changed the actual assignment, we would then start to collect more information about why that assignment was not good. And so that starts to then point to other pieces of information or context that we don't have access to that is important to that. So those are a bunch of things that I think about. What I want to do now is we're going to do a exercise around role playing. And this is probably the lowest fidelity version of prototyping that you can do. It doesn't require you to actually make anything. It just requires you as people to interact with each other. And so role playing is stolen from service design. It's very much related to design thinking in the sense that it's about putting the humans at the center of this process. In this case, each person will assume a particular role or behavior, and I'll talk about what those roles are. You can always use costumes or props. Service design people love building service areas out of cardboard for people as a prototype. And then board games are another way to do this type of play. And this is a really interesting example from a company called Future Ice that's out of Europe that does some really interesting stuff around not only card decks for machine learning, but also this IoT service kit and how IoT can be built. It was really, really interesting if you want to check it out. So why do we do this? And why do we do role playing in particular? And the reason is that interactions between people and machines are important to understand and expose issues. And so we did that a little bit with our ideation. We thought about what are our assumptions or expectations for how the machine will interact with people, but we didn't actually try it out yet. And that's where prototyping comes in. And then I think what's really interesting about role playing is it makes it very visceral. So not only will you, as role playing different aspects, you'll feel much more immersion in the issues that will come up when you're doing that role play. So the way setup works for this is I'm actually going to pair you into two people, and we can do that in a second. And there's going to be two actors, okay? So usually there's as many actors that are necessary to help simulate or prototype a particular experience. There's usually what I'll call a creative director, and that creative director is more of like the manager of the role play. And so in this case, I'll do that, so you guys don't have to worry about it. But they start and stop the role play, they capture notes, and then they add circumstances, what's really interesting about this scenario role play is that we want to see how things change over time as well. And then the stage is going to be the two seats that you're sitting in, so you don't have to move anywhere. But it ends up, it's helpful to have a separate place where people can be seeing it and other teammates can actually observe the role play at the same time. So this is an example that I really love.
I really need a proposal. I don't want to waste your time.
Fill out this request for a proposal.
So she's pretending to be a website.
All right. Can I just shoot you an email or something? Is there an email anywhere?
Fill out the request for a proposal.
Okay. All right. Contact person. That's me, right?
Contact person.
My name? I guess that's my name. I mean, how often do people actually fill out this for other people? Usually.
So she's only able to say the things that are actually on the web form. Yeah.
All right. I'll fill out my name. Enough, right? Okay. Email. That makes sense. I assume you need email to contact me. Okay. Great. Email. Telephone. Do you really need my telephone?
Telephone.
Why do you need my telephone?
You need to fill out everything.
All right, telephone.
Yeah, so you can see that through that experience, we actually saw how hostile that web form was for this particular need. Not that she was meaning to be hostile, but in the end, that role play was really helpful in discovering that issue. And so that's what you're going to do right now. So I've created roles for you that I will show you in a second. And using personas or empathy maps are great ways to do this. And so generally the way that we would do this is I would have you break into teams. I would give out roles to each person on a secret card where only you see that role. You would study it for a certain period of time. And then essentially we'd give the prompt and you'd get started with role playing. And through that time, you would start to collect notes. The creative director would. You would start to actually be part of this experience. The creative director will intervene with different prompts as time goes on. And then afterwards, you'll discuss the notes that come out of that. So I want you to break into teams of 2, and different teams of 2 than the teams that you just were in with regards to discussing driving. So try to find someone else. Sorry. So for each couple, I want one of you to be an autonomous vehicle, okay? And I want one of you to be a passenger. I do not want you to in any way physically touch each other, okay? Just to be very clear. And these are the notes that I'm going to give you for your role, okay? So I want you to think about this, and what I'm going to do is I'm going to actually specifically give you 2 minutes to sit quietly, and if you want to, write down notes, but think about what this means from the standpoint of what you will do for the prompt, basically. And try not to look at the other persons if you can avoid it, but yeah, so you guys coordinate and decide who's the AV, who's the passenger. And I'm going to give you 2 minutes to just think about it, okay? And here's some questions I want you to consider. So what is important to your role? How will they act? How will you act in this situation? What will the interactions look like? And what limitations will there be? So here's the prompt, okay? So I'm the creative director. The prompt is, how might we help a passenger get around town to do their errands quickly? Okay? And as part of this prompt, I'm going to give you basically 5 minutes to do role play. So I'll put back up the things, if you guys do not take notes about what your tasks were, I'll put them back up on the screen. But I want you to assume that basically the car is somewhere, passenger doesn't know where, the passenger needs to go do something, and they're sitting in their house right now. I want that to be the beginning scene, okay? Any questions before we get started? I think I'm not going to specify that. That's a great question. And so that's something that, so that's a great question. What UI does the car have, right? And what I would like you to do is, as the person playing the AV, you have to describe what the UI is, right? And then you, as the passenger, have to interact with that UI in some way. I think, well, so that's a great point. Your how might we prompt is to help a passenger get around town to do their errands quickly. And so a lot of these are, quickly is an overloaded term, right? It's a suitcase term. So you decide how that works. Get around town to do their errands. That's based on what the person needs, right? But I think, like, let's just pretend, again, to make it easier for the AV person, if they just were to think about that they were sitting in the car as a driver, what would that mean? That's probably a good way to start that, right? But because you're an AV, there's a lot of other things you may know about the world that a person sitting in that vehicle would not know, okay? So I'm going to give you 5 minutes, and then I'm going to interject at times, okay? And I want you to also, another thing that's important about role play is I want you to pretend that you're actually going somewhere, so it's not like you teleport to the next thing, okay? So I want you to actually talk about, like, what does it mean about how far and things like that. And if you need to have that discussion, have that discussion. But if you are, as a car, don't want to bother someone, don't bother them, right? Like, that's up to you. So I want you to now role play this. I'm going to give you 5 minutes, and I'm going to interject at a couple different times with things. And I'll put back up those prompts, though, okay? So I'd like to, as the creative director, I'd like to add one situation. So the child that you just picked up, or may have picked up, suddenly has to go to the bathroom, like urgently. And so, so go ahead, role play. Okay, and I'd like to intervene with one other thing. So the AV, one of your sensors has failed. So I have a prompt, I have another random prompt for you to discuss. So what if the AV asked for human help?